Hey there, welcome to Life Noggin. You know, every time you look up at the sun, you can't help but wonder, gosh, that ball of hot gas is so much older than me. I hope it doesn't die before I do, otherwise I'd have nothing to stare at during my morning commute. Well, don't worry, that ball of hot gas isn't going anywhere for at least another 5 billion years. But that doesn't mean it's any less immortal than you are. In fact, you're actually a lot older than the sun, which probably means you're older than you think. In this video, we'll explore where our bodies come from and how we might be a lot older than we look. The universe is full of some pretty amazing things. Black holes that play hopscotch with space-time, planets made of diamonds, and enough variations of the chemical compound water to fill every ocean on Earth more than 300 trillion times. But maybe one of the most special things about the universe is the way it recycles. I mean, if all the matter in the universe started out as hydrogen and helium, then everything we see around us must also be made of those two things, right? Wrong. Stars create elements heavier than themselves. For example, our sun is mostly hydrogen and helium with trace amounts of elements like oxygen and carbon. These elements are called heavy because when it comes to atomic weight, these elements are really heavy weights. Meanwhile, hydrogen and helium are known as light elements because they have very low atomic weights. So, while the sun does contain some heavier elements, it's mostly just hydrogen and helium. However, the sun doesn't make these heavier elements itself. It has to borrow atoms from its food source, hydrogen. Hydrogen atoms have one proton and one electron buzzing around it. And inside the sun, these atoms get squeezed together so tightly that they have to start borrowing electrons from each other to stay stable. This creates helium. After helium, things get kind of complicated. Each of the sun's layers gets progressively hotter and squeezes hydrogen into helium. And after helium, there's beryllium, boron, carbon, nitrogen, and oxygen. At each stage, the atoms get heavier until they become iron. At this point, the core can't create any heavier elements. Instead, it has to steal protons from other atoms to keep making iron. This process only works for so long, though, because at some point the core runs out of free protons. Once the core can't build any heavier elements and has no more protons to steal, the star dies. The outer layers expand outward, and the core collapses inward. Then, all of the elements above iron get thrown out of the star in a stellar explosion called a supernova. This is important because many of the elements found on Earth aren't found on the sun. Carbon, nitrogen, and oxygen make up about 89% of Earth's crust by weight, but these elements only make up about 1% of the sun. If this is true, then where did these atoms come from? We know that supernovae can launch these heavy elements into space, but why were they in our solar system in the first place? Well, billions of years before our solar system formed, our sun was a glowing ball of hot gas. It formed from a cloud of mostly hydrogen and helium, along with small amounts of heavier elements that were kicked out of a nearby supernova. A whole bunch of stars lived and died near where our sun would eventually form. When they died, they threw their guts into space, creating a nursery of heavier elements. Eventually, our sun gathered enough mass and gravity to form its own planetary system. But it didn't make its own rocky planets. Instead, it grabbed a bunch of material from that nursery of heavier elements. This material included the carbon, nitrogen, and oxygen that make up our bodies today. So, next time you're on a first date and your companion asks, "What are you made of?" just tell her, "I'm made of star stuff," and she'll either think you're being poetic or run away because you're a total weirdo. Okay, let's get back on topic. All of this means that some of your atoms are a lot older than the sun, and if we go far enough back, some of them might be a lot older than the Earth, too. Our planet formed about 4.5 billion years ago, but some scientists estimate that the oldest elements in Earth's crust formed 6.6 billion years ago. That means that some of the atoms in your body could be nearly 2 billion years old. But wait, atoms are never destroyed. They're always reused. Does this mean that you're literally a dinosaur? Well, not exactly. You see, atoms are recycled all the time. When a star explodes, its atoms get thrown into space. Later, those atoms might form part of a new star or maybe a comet or a meteoroid. And after that, they could land in a puddle that eventually becomes part of a river, that eventually becomes part of an ocean that eventually gets turned into rock, that eventually gets blown apart by wind erosion, that eventually falls to the ground as sediment, that eventually turns into more rock, that eventually gets squished into metamorphic rock, that eventually becomes part of the mantle, that eventually erupts through a volcano, that eventually makes new igneous rock. And if none of those things happen, it could just sit there for millions of years. Either way, eventually it finds its way into rocks and soil and water, which eventually gets incorporated into living things. This means that atoms are used over and over again by countless living things throughout history. Some of the carbon atoms in your body may have been part of the first life forms to inhabit Earth. Maybe some of the nitrogen atoms in your body were once part of a dinosaur. It's possible that some of the oxygen atoms in your body came from the first plants to grow on Earth. But even if you're not literally a dinosaur, you're still related to them in a weird way. When you eat, you take in molecules that break down into atoms. Then, these atoms get rearranged and used to build new molecules that make up you. So, if you eat a plant that grew from Earth's soil, you ingest those atoms, and potentially some of them will end up in your body. This means that the atoms in your body are a lot older than you, but they're also a lot younger than you. Yes, your body replaces its atoms all the time. For example, half of the carbon atoms in your body are replaced every year. Most of the other atoms in your body turn over between 4 to 7 years. So, while some of your atoms are super old, others are relatively young. The question is, how old are these atoms? The answer depends on what element we're talking about. Every second, the human body makes about 75 trillion cells. This means that atoms that make up those cells are replaced at different rates depending on what element they are. Cells in the body replace their carbon atoms once a year, so carbon atoms that make up your body are about 1 year old. Iron atoms, on the other hand, are replaced every 200 days. Calcium, phosphorus, and zinc atoms are replaced every 10 to 30 days. Sodium, potassium, magnesium, and iodine atoms are replaced every 4 to 8 days. Chlorine atoms are replaced every 3 days. And sulfur, nitrogen, and hydrogen atoms are replaced every few hours. So depending on what element is in your body, it could be a few hours to a year old. This means that your body is constantly recycling atoms, but it's also constantly taking in new ones through food, air, and water. So you're never really the same person from one day to the next. Your atoms are always changing. And while some of these atoms are technically older than the sun, they're also much younger than you. Ultimately, we're all just big balls of plasma trying to get by. So remember, no matter how old you are, you're never too old to learn something new. Unless you're a star, then you're never too young to blow up. Speaking of blowing stuff up, we love blowing your minds with science videos here on Life Noggin, and we have a whole playlist dedicated to space. So click here to watch another space video. As always, it's me. This has been Life Noggin. Don't forget to keep on thinking.